right, here we are again, Unit 8 test review. I already went over the first part, so the second part I'm just going to go where I left off. So I just finished number 12 on the back, and now we're on 13. I have it written over here. We're still on identities, so the goal of these problems, prove the following identities true. That means you're going to make the left side look like the right side, and the key word is identities. We do not move things from one side to the other with the equal sign. So you cannot move things over here. We're not going to add or subtract or multiply or divide. We're going to do that when it says solve. So confusing, yes? The keyword is identities. You stay on your own side, okay? So here we are at 13. And usually, not all the time, but usually rule number 1 is change everything to sines and cosines, but we already have that. Rule number 2 would be to add fractions, but there are no fractions to add. So rule number 3 would be to do like a division of fractions. There's nothing there. Okay, so we're left with like the last two ideas, and that would be to multiply or factor. So do you guys see down here where we have 1 plus cosine times 1 minus cosine? We're going to multiply that out. And if you know what that is equal to, like you already know, then fantastic. That is great. I'm going to actually multiply it out just in case people don't know. So what we're going to do is we're going to FOIL our first 1 times 1. Outer would be 1 times negative cosine. Inner is cosine times 1. We put a plus sign here. And then last would be cosine times negative cosine, would be negative cosine squared. Cosine times negative cosine, positive times a negative, negative. Cosine times cosine is cosine. And we're trying to make this side look like cotangent. It looks like a mess right now, but we will see. Okay. Let's clean it up. So we have sine times cosine in the numerator. We're not touching that. There's nothing to do with this one right now. Oh, what do we have here? Minus cosine plus cosine. So what happens to those? They cancel to 0. So if you say they cancel out, well, you said they cancel out when you have division to 1. These cancel to 0. So make sure you're saying cancel to 0 or cancel to 1. It's a big deal. Okay. Does this equal cotangent yet? No, not at all. But we do have a 1 minus cosine squared, and I kind of went over that in the last video. We know our Pythagorean theorem is sine squared plus cosine squared equals 1, and we can rearrange that. So do you see how this says 1 minus cosine squared? If I were to subtract the cosine squared to the other side, I would get 1 minus cosine squared is equal to sine squared. So I'm going to substitute this out, 1 minus cosine squared. Anytime you can get rid of a plus or minus, that's a good idea. Because, why? Plus or minus limits you. It means you can't divide things and cancel because we cannot divide with plus and minus. We can only divide factors, and factors are being multiplied. Okay. I lost where I was. 1 minus cosine squared, 1 minus cosine squared is sine squared. Here we go. Do you see how I use S and C up here? You can do that in your scratch work in the margin, but in your proof, it needs to be the full sine or cosine. All right, what do you notice? So we got rid of, like, this is what I was talking about, you guys. Do you see how this cosine's right next to a minus 1? Or sorry, a minus? You are not allowed to do that. Oh, you want to give your math teacher a heart attack? You cannot cross these cosines out because this one's next to a minus sign. Okay, but now that we've gotten rid of the pluses and minus, now we can cancel sine over sine squared because their sine is a factor and sine squared is sine times sine. Those are all factors. They are being multiplied. Recap, you cannot cancel next to a plus or minus. You can cancel anything being multiplied. Okay, so what happens here? We have sine over sine squared. One of the signs cancels, but since this is sine squared, there's a sine in the denominator. Cosine over sine, what's cosine over sine? Sine over cosine is tangent, so cosine over sine must be cotangent. Is that what we were trying to find? Congrats. There we go. We did a lot of practice. This was 8.2. less than 8.2 if you want to look at some more examples. Okay, now we're in solving. Solve the following for the unknown variable between 0 and 2 pi. So theta, this is a clue. This tells you two things. Ready? It tells you that theta is in radians. It also tells you that theta is positive and less than 2 pi. Okay, that's what that means. Positive, greater than 0, and less than 2 pi. All right, let's do it. I love number 14. I love it so much. I love it, meaning look out for it on a test, okay? Because you can do this the teacher way, the trig function way, or you could just use inspection, okay? Proof by inspection means you know the answer. That's it, you know the answer, okay? So the question is, theta, where is the cosine value equal to the x value on the unit circle? Where, oh, I froze. You keep thinking. Where is cosine equal to sine on the unit circle? Cosine is x and sine is y. So we're saying, where is the x value equal to the y value on the unit circle? Do you know where that is? Do you know where that is? Let's do our little 1, 2, 3. 1, 2, 3, 1, 2, 3. Okay, right here I see that they are the same. And do we know these angles? This is a small angle, middle angle, big angle, and this middle angle is pi over 4. So we know the cosine is equal to sine when theta equals pi over 4. Okay, what else? Where else are they the same? If you go back to quadrant 2, they're not the same because the x value is negative and the y value is positive. So we're going to go down to quadrant 3, and in quadrant 3 we have negative, negative. I don't know why I switched to pen. Negative 2, negative 2. Now these aren't 2's, right? They're square root 2 over 2, square root 2 over 2, square root 2 over 2, but this is my margin. This is my scratch paper off to the side. Okay, what is the angle down here, that quadrant 3 pi over 4 angle? Let's see if I remember. Pi over 4, 3 pi over 4, 4 pi over 4. This must be 5 pi over 4. I can adjust. That's it. How do you know? I know. That's it. You want to, I don't know, you want to see another way? Let's do this quickly. You could divide both sides by cosine. How'd you know how to do that? I'm the teacher. Cosine divided by cosine is 1. What is sine over cosine? Tangent. So we're really saying, where is tangent? What's the arc tan of 1? Where is tangent equal to 1? Well, we know that. We know tangent is equal to 1 when the y and the x are the same value. Y divided by x is 1. So we know tangent is equal to 1 at pi over 4 and 5 pi over 4. Cool. Let's do another one. Here we go. We're solving now, so we got to get theta by itself, okay? We're not doing trig identities. You ready? Get set. Step 1. Get the trig function by itself. So do you see the negative 3 we need to move, the 4 we need to move, and the square we need to move? Now, you've been moving this 3 and that 4 for about 3-4 years now. So you should be able to say cosine squared is equal to what? What number? 3 over 4, like that. Now, how do we get rid of the square? The power of 2. We're going to take the square root. Every time we take a square root and we're solving for a variable, we have to put plus or minus. Plus or minus square root 3 over 4. Okay, how do you take a square root of a fraction? You just do the square root of the top and square root of the bottom. So we have cosine theta equals plus or minus square root 3 over, what's the square root of 4? 2, like that. Okay? So we have two answers here. Theta will equal the arc cosine of positive square root 3 over 2, and theta will also equal the arc whose cosine is negative square root 3 over 2. All right, my work is so beautiful here in my math problem. I'm going to go to my margin. 1, 2, 3, 1, 2, 3. Okay, I only need the x value. Sorry, cosine is what value on the unit circle? Cosine is the x value. So this is x, x, x. And now that I know that I'm here, I have my x value, and I know this is the little angle pi over 6. Okay? So this theta is equal to pi over 6. The other positive square root 3 over 2 is down here, and that's at, it is not 7, it is, how do I turn that into an 11? Ooh, look at this magic. 11 pi over 6, because it's right next to 12 pi over 6. 12 pi over 6 would be 2. Okay, but we also get to write down the negatives. Not every time do we get to write down all 4 answers. That's going to be back over here. Remember, 180 is 6 over 6. So just before you get to 180, we have 5 pi over 6. And then just past 180 is 7 pi over 6. All right. Fun. Isolate the trig function. We had to take the square root, then do the arc sine or arc cosine, and then get theta by itself, which theta already was by itself. But this theta is not by itself. See that 2 there? Okay. So step 1, get sine by itself. So we have sine of 2 theta is equal to what? How do we move this over? We're going to divide by square root 2. Rationalize the denominator. Here we go. Just, trying my best to make this exciting and entertaining. I enjoy this. I don't know if everyone enjoys it. I think it's fun. It's like solving a puzzle. Okay, now we have, where is this sine equal, you know what? We're going to say 2 theta is equal to arc sine of positive square root 2 over 2. All right, we're pretending, every time we're pretending we don't have a unit circle. You should not be using your unit circle, okay? Here we go, 1, 2, 3, 1, 2, 3. We're here because sine is y, and that's the middle angle. So 2 theta, am I still on the screen? 2 theta will equal pi over 4. And then where else is y positive? Y is positive in quadrant 1 and then also in quadrant 2. So this middle angle is pi over 4. And then over here it's going to be 3 pi over 4. So 2 theta equals pi over 4, or 2 theta equals 3 pi over 4. We're not using the angles in quadrants 3 and 4 because those would be negative. Okay, theta is not by itself. Theta has a 2 next to it, so we need to divide by 2. Division by 2 means you multiply in the denominator. Division by 2 means you multiply in the denominator. Again, these really should be in your head by now. We're doing this in our head. And if you go, oh, pi over 4 divided by 2 is pi over 8, so 3 pi over 4 divided by 2 should be 3 pi over 8 as well. Everyone okay? Hanging in there? How many more do we have? 17 and 18, 2 more. I love 17 because I got this wrong when I was in high school. I tried to divide both sides by cosine and cancel, and my math professor said that I just deleted one of the answers, and I felt bad. I got called out. So we have to subtract this cosine and set it equal to 0, and then we have to factor. Why can't we just cancel? Well, my math professor in college said if you just cancel it, you're going to lose some of your solution. So we have to factor. It's not an option. Okay, do you see what I did there? Subtract the cosine, factor out the cosine, and then you should know this. Cosine squared minus 1 is a difference of 2 squares. Cosine plus 1 times cosine minus 1. Okay, from here we use zero product property. I'm going to pause it and just write the answers because I'm running out of time. Okay, so zero product property was set each factor equal to 0. Where does cosine equal 0? Do you know that yet in your head? Cosine equals 0 at pi over 2, 3 pi over 2. Where does cosine equal negative 1? At pi. And where does cosine equal 1? At 0 or 2 pi, depending on which one's included. Here, factors.